Hello everybody, today is a special day. I got a little bit of red face from flash burn. I'm supposed to be wearing my PPE, shh, don't tell no one. But why it's special is because I have my friend Mike Goodman here. Mike Goodman is a famous person in the hot rod industry. He's the most humble person you'll ever meet, but he used to own Ernest Charlie's Speed Shop here in Chattanooga, and he's since then retired, and I have the privilege of giving him some welding tips. He's come prepared today to ask a bunch of questions about his TIG welding. He brought a bunch of samples that he's been welding on and wants to get better, so I'm hoping that I can give back to him by sharing some information with him to help him meet his goal.
And I know from being around you, Michael, and Garage Bound that I'm going to get some practical knowledge, and I can get away with a lot of hearsay and a lot of data and just get down to practical application. And you said you would share that with me. And so,
yeah.
You know, I brought the samples I had because I think most of them are inconsistent. A lot of it's mediocre, and it kind of gives you an idea of where I'm at. And I know that I'm not going to get perfect and not do art because at 74 years old, I'm shaking everything. So, okay, so here we go.
Okay.
So give me an idea about, I know that there's different types of tungsten and everything seems to go toward 2% thoriated, but what do you use here at Garage Bound day in and day out?
Well, since I already know that you have an inverter-based welding machine, I would suggest that you use a tri-mix. So this is several different types of rare earth elements, and we use this pink tip from Blue Demon, and that way you don't have to keep up with green, you don't have to keep up with red. This pink stuff, this tri-mix, you can use it for all materials, so that way you can just ditch everything else and not have to worry about finding, oh, this, that, because sometimes the color wears off on the tips, and just grab one type of tungsten and ready to go.
Now I know why when I arrived early today and looked around the shop, I saw a lot of this.
A lot of Blue
on the
Demon
tables.
stuff,
Yeah, there you go. Okay. That's great. And you told me I could use that for low carbon steel, mild steel, stainless steel, aluminum, whatever I might run across.
Yes, sir.
Okay. And so what's the primary diameter that I should be practicing with at this stage of the game?
Well, if you're using something like, if I'm like down to like 1/16 material, I'm going to match that with the 1/16 tungsten. But if I step up above 1/16, I'm probably going to switch to a 3/32. And then since your machine only goes up to 200 amps, I wouldn't worry about trying to get a 1/8 tungsten.
Okay, and are there applications where me as an enthusiast that I might want to use a real small diameter filler rod like 040 or MIG wire 035 or something like that?
Yeah, if you're welding something super thin that you keep blowing through. So a good tell is if you're welding something so thin and you're using the 16 tungsten, you can't get the arc control to go down as low as possible with that larger electrode, then you would want to step down to something even finer.
I should have seen you about like 30 years ago. No, you weren't even around 30 years ago.
I was barely born. What are you talking about?
Okay, and so I read all kind of things, and being in the industry, there's always talk about different tips and stuff and different profiles. What am I looking at real world?
Well, unfortunately, I never had any technical training. You know, so about the profiles and stuff, when I look at some of your welds, I guess one of the biggest thing would be is that you want to match up the right size filler metal, and then when you're doing the puddles, I'm going to show you when we get into the welding here a little bit how to pulse and build each puddle, and you're watching the outside profile of that puddle to make sure that you don't have any undercut on your finished product.
Okay, thanks for that. And here's something. You know, I think I started this process totally wrong. I was building a street rod. I was thinking body panels and that kind of thing. I really struggle with problems with doing thin material. Then when I got into 1/8 and so-called coupon, 1/16 and 1/8 and so-called coupons, I found it was much easier.
Yeah.
So so for my practice, am I correct that I now have realized much later that I needed to start with thicker material and go thin as opposed to the other way around?
Yeah, that's probably, I think a lot of people, if they start with real thin material, they get discouraged and they stop welding.
It's easy to get discouraged.
Yeah, but I don't do a ton of really thin stuff, you know. Garage Bound is our name, but I'm not like super like worried about TIG welding, you know, car panels and stuff. But I'd probably have to refer you to maybe some of Ron Cavell's videos, because he uses TIG when he's welding all his panels that he metal shapes together and stuff. And he's not just running a solid bead. He's just going to do a tack, let it cool, tack, let it cool. You know, the concentration of heat is in much smaller area, so you get a lot less distortion of the metal when you do when you are actually depositing metal, and then it cools, and then you have extra metal, and then it shrinks and pulls and moves all your metal around.
Right, and I'm familiar with Ron's videos and have met him at the SEMA show and those kind of things, but you know what the big advantage for me coming to Garage Bound is I know you do all this structural stuff, and structural is what's gonna get me as an enthusiast in trouble if a decently critical weld doesn't hold or that kind of thing. And I don't know, correct me here, you've had an early video on a 125-foot long trailer that came in that would articulate and had broken, and everybody wanted to turn down that job, and you tackle that and send them on their way.
Yeah, we did that. I don't forget how many millions of pounds that trailer held, and we were doing a pretty critical part. And it's like, it's just metal. It's already been done once. I'll look at it, see how it was done, cut it out, and start over, and maybe add more material, and you know, do a better job.
And that's what I'm after, so that when I repair my neighbor's lawnmower handle, it doesn't break and trip him up in the yard. Okay. Okay, and what's my best way to monitor the amperage that I set at and the voltage that I see on the machine, or not even need to be concerned with that?
So I usually don't. What I usually do is I use my foot pedal like a gas pedal in a car. I set the machine to all the way open, and then I'm watching, like my TIG welder, I get 400 amps. If I push that pedal down all the way, it'll just destroy smaller stuff. But I'm easing into it, like I'm coming up to speed or getting on the freeway on-ramp. And then I'm watching the metal, what it wants, and then I just adjust, like hold my foot in one place and adjust for how much the metal is going to tell you that it needs. You could blow a hole through that really quick.
And so I obtain that knowledge just from experience through welding.
Yeah, and a lot of it's going to be like that. The way you're going to get better is by making these mistakes and figuring out what to alter so that you don't make the same mistake again.
Yeah, in fact, I think that I'm correct in saying that I was going totally wrong early on by trying to do these welds like I would see online, when in reality I need to be concerned about not putting the tungsten in the pump.
Yeah.
My concerns is it how do I make an assessment on how much tungsten stick out that I need to have, just as a point of reference to start?
If you're using a smaller cup, this is a number 7, and you go out too far, it's going to start sizzling the point off of the tungsten, right? So again, since I never had any critical training with any kind of schooling or anything, I've always just found that I push it in, and that's about the space on my finger, and it ends up being somewhere between 3/16 to a 1/4 inch on like a number 7 cup, and that works really good for aluminum.
Okay, that's good. I learned something there. I hear a lot of talk about a gas lens. Is that something I need to consider? Are there disadvantages there? When would I use that? What do you use here at Garage Bound?
Yeah, so we do use gas lenses when we're doing stainless or carbon. Sometimes carbon, but more with stainless, just because I'm trying to get those pretty colors and all that, you know. We use a FUPA 12 by Michael Fierick Company. And when you have a gas lens and you have a wider range of dispersion of the gas, you can actually run your tungsten out a lot farther because it's going to cover. And if you ever online, if you watch videos, they have like fog that they put through these gas lenses, and it kind of shows you, you know, how big of an area that is actually covering. So most products that you buy a gas lens will show you the flow coming out of them. So if you needed a larger area, right, then you can adjust your cup size from that. They even have, Fierick even has clear ones, clear glass lenses, gas lens and nozzles that you can actually see through if you're in a position to where something else is in the way and it's covering and you need to see through the cup to see where you're welding. So there's a lot of different options, and they come in real handy for carbon and stainless.
Okay, so you actually use a clear cup
sometimes
here at Garage Bound? Okay,
yeah,
so there's a time and place for that.
Yep.
Okay.
It's just like having 2 different kinds of hammers. You're not going to use a claw hammer for everything.
And so what is your go-to cup diameter? I've been using the number 8. Am I right there, or do I need to be larger with the gas lens?
You should be. Are you using a gas lens inside your number 8, or are you just using a collet body?
No, I'm using a gas lens inside.
So this is you have a gas lens inside your number 8?
Yes, and you know what? I had several of those, and I thought that I would be fouling them up, but I see that they're pretty durable. And
yeah, they are pretty durable. They just don't like it when you get sputters, and when you're like TIG welding carbon steel. What causes that is the mill scale. like will kind of sputter and pop back in there. So if whenever you're welding carbon, if you can just take the area that you're going to be welding and try to get that mill scale off by grinding it off, then you'll be in a lot better shape, and that's going to make your gas lens last longer.
Okay.
I'm sure you're not doing a ton of overhead welding. So the other thing
You know what? I haven't even attempted overhead welding, so that's somewhere down the road.
Yeah.
Okay. Amp control is the 1 amp per.
That's too technical for me. I don't know.
Okay.
I always just see how the electricity is reflecting and reacting with the metal, and make adjustments with my foot
Okay,
pedal.
so watch the puddle and go for there. So with the Furic cup, the gas lens, a number 12 cup, or any of these, what would my go-to gas flow setting cubic feet per hour be?
20 to 25 if there's no wind. If you're in a building with no wind or no fan blowing on you, 20 to 25 has always worked for me.
Okay, well, my own experience, I was looking at these numbers like 5 and 10 and whatnot, and that wasn't working for me at all, and I kept going up, and for a while I was real concerned that, well, maybe I'm using too much gas. Then I realized how inexpensive gas was.
Yeah, right.
So,
they pull it right out of there.
Quit worrying about gas and just, start worrying about the weld.
Okay. What I typically do is I push the foot pedal, and if it goes psh, if I can hear it making that psh noise, then I know I'm going to get coverage on my weld.
Okay.
Because it only needs to be within a 1/4 inch of my cup, because my tungsten on like a number 7 is not sticking out any further than that.
Okay. And so day in and day out, from a practical application, am I looking for a smooth TIG weld, or am I looking for ripples or dimes?
I always try to do a dime shape, and there's several ways of getting that. You can stack each puddle, which I do a lot with aluminum. I'm creating every dime, creating the outside profile by fluctuating the electricity. Or you can find the right temperature or the right amperage, just hold your foot there and slowly dab, and you might want to move your TIG hand back and forth a little bit too.
Okay, and so if I'm laying out a TIG weld that is essentially pushing the torch forward, dabbing along, and after all is said and done in practice, I end up with more or less a perfectly smooth weld. Is that necessarily a bad weld or an incorrect weld?
No, I don't think so. No, not having the ridges is probably, that consistency is pretty good.
Okay.
Yeah.
Okay.
And the other thing that I do, say like I need to weld, what is this, 8 inches? I'll do what's called simulation, and I'll take and make sure that I can comfortably move that entire area without having any starts or stops. That way I have one nice consistent weld.
Okay, and I noticed how when you just grab the torch right there, tell me about handling the...
Okay, yeah, so there's no right or wrong way to hold this thing. There's been times where I hold it like this. There's been times I turn it around and hold it like this because it's more comfortable. Get off that. Like this, right? Just depending on how you gotta get in there. The other cool thing about this CK torch is the CK230 FX, which means flex head, is that you can flex the head, right?
Okay.
To get down inside there, which you could get a torch like this, and it comes in really handy, especially when you're going around round things, because you might only be able to reach this far, but you can get another 3/4 inch of weld by
And so
angling
what
the head.
brand torch is this?
CK Worldwide.
Okay.
Yeah.
I've got a flexible head torch, but it doesn't flex as much as what you showed me there, so I can see that benefit in that brand.
They say not to go past 45 degrees, and I've ruined several by like just really wrenching on it and having it at 90. When you turn it back, it cracks the little copper hoses or brass hoses that are in there. There's brass lines, right? So,
Right.
I mean, anything, if you take any piece of metal and you bend it back and forth enough, like a paper clip, it ends up in 2 pieces. Same thing as this.
And while you've got the torch in your hand, I see that you've got the 6/7 inch common.
Yep. I like this for a lot of reasons, because sometimes I'll have to hold on to that. I like it because I can use a full stick of tungsten. A lot of people like to grind both ends of their tungsten, and then you lose track of what tungsten it is. Even though we primarily only use the pink tungsten, I have a lot of welding consumables, old ones and stuff too, but if you grind both ends, you don't know what you have, right? So, but there are a lot of times when I need more access that I'll have just a button cap on here, And we've been on mobile jobs before where we didn't have an extra button cap, so I just chop this off and get a little piece of wood and jam it down in the hole, because this is hollow, and then I have a button cap.
That's good. That's good.
Yeah.
And while you've got this in your hand, from my experience with a welding table, I have not this nice, sharp edges. I wore through the covering.
Yeah.
Realized immediately that the shocks and the electrical jokes I was getting weren't necessarily from doing something wrong. They were actually coming through here.
Oh yeah.
So is this?
Yours is probably an air-cooled torch. You don't have a water-cooled torch on yours, right?
I don't have a water tool.
Yeah.
That's correct.
So this one has cables, like there's coverings in here. Like the blue one is for the argon, and the red one actually has a copper line inside of it, and that's where, I'm sorry, the blue one is the return line. The red one is where the water comes through, circulates around through here, and the black one is for the shielding gas. Right?
Okay.
So if you have a hole in this line, you'll know it because there'll be coolant all over everywhere. It'll pump all the coolant out. So, and that's probably, you know, you'll lay it on something inevitably that's hot, and over a period of time it'll burn holes in it and stuff.
How do I know if I've got my helmet adjusted dark enough or if I've got it darkened too much? I'd say if it's darkened too much, I'm not able to see, but how do I know that I'm not going to hurt my eyes?
So I would never TIG weld on less than like 11, shade 11.
Okay, I'm way off on light. Okay.
Okay, so yeah, I would darken it up, and then the thing that would help you too is your sensitivity, right? If you're welding inside, you can have your sensitivity like at 4, right? That way it picks up the arc as soon as you do it, and then the weld puddle is not so sensitive that the weld puddle glowing still keeps it dark. Now, if you go outside to weld and there's any kind of ambient sun coming through the back of the screen or stuff, you might want to turn it down to 0.
Okay. So how about protection? Do I want some type of apparel? Can I weld in just a long sleeve T-shirt? I've seen people weld in short sleeve shirts.
I do it all the time, and it's probably not right. So the arc could cause skin cancer over time. I've been told. Anytime I post pictures or videos, all the safety gurus are getting on me about this. So I basically learn from them when they're bitching at me about doing something wrong.
Well, my friend that had a career pipe welding, he said they just put sunblock on and started welding. So
Yeah.
I don't know.
I don't know
Okay,
either.
I just said.
Yeah. Miller will still post my pictures if I have a long sleeve hoodie on and gloves without welding sleeves.
Okay. Well, I brought this in case I had to have it to keep you happy. So.
I'm easy to keep happy.
I think you've covered my questions.
Okay.
You know, in my life, I've never watched anyone TIG weld. Can I have that opportunity here at Garage
Yeah,
Mountain?
let's do it. Yeah. So get some of your coupons out. You brought coupons, right?
Because I didn't. You know, I was more interested in watching someone weld instead of having me weld. So I just brought. But I've got enough either way. I mean, I'm going to embarrass myself regardless. I have with a lot of my questions. But you know, this is typically what I'm fooling with.
Okay.
And there's some other little pieces, so I think I could see about all I wanted to see. If you wanted to go left or right or long ways or
so what I'd usually do with
stand one up or
coupons,
anything you want to do.
back here with Mike. So what I want to do is I'm going to tack these coupons together. That'll give me 1, 2, 3, 4 fillet welds to be able to do. And with these 4 fillet welds, I'm going to show you several different techniques that I've learned over the years that I use daily on just a lap weld.
Okay, are these, will you consider those clean enough? You obviously do.
Yeah, I consider those clean enough. There's no rust. There's no heavy mill scale that looks like it's going to chip off and get in your puddle.
And wipe it down with acetone. Is that what you do?
That's a step I don't do.
You don't. Okay.
I don't
do you wipe them down with anything?
A grinder, usually.
Okay.
We have to do so many repairs. You know, I just try to get it as clean as I can with a cutoff wheel or a grinder down to shiny metal and weld it. Yeah.
Okay.
So again,
are TIG repairs a significant part of your business?
yes, we do a lot, and on site outdoor TIG welding, aluminum, stainless,
Okay.
lots of aluminum welding because we're fixing 53-foot semi tankers often. You know, It's not just easy to pull it in the shop. I don't even think it fit in my shop. So I'm going to do it outfield. And sometimes if it's windy, we just build a barricade around ourselves and keep the wind off of us so it doesn't blow our shielding gas away.
Okay, so TIG in general welding, that's not a novelty act, that's an integral part of the business.
My business, yeah.
Okay.
Yeah. Being able to weld thick aluminum mobily is an advantage I have over some of my local competitors. They're not going to try to go do that, but it's like, why not? It works great for me. You know?
Okay, so where do I position myself so that I get the best view of what you're doing?
Right here.
Get behind you?
No, from right here is fine.
Okay, and that's not going to disturb you with your rod?
No, I can bump it into you and still do it under the.
Okay, just tell me and I'll drop my.
Okay, drop your hood. We're going to do a couple tack welds. Oh, do we have a rod?
Rod mounted. Just reach up there and hit those and fuse them.
Oh, just fuse them, yeah.
Yeah. So that's good.
Okay, it should be tacked enough where I can at least spin it around without it moving. And then I can get this tack weld here. Ready? Yeah. See how I held that filler metal in there until it came up and touched the top plate?
That's it.
Alright, now that I have that, I'm going to go ahead and tack this side too. That way they don't open up as I'm welding like a clamshell. Is it too dark still?
Yeah, it really is. I may be in the best position for me if I'm going to be able to see it. You know, it may hurt, may or may not be hurting my eyes.
Okay, we'll do another tack weld here. Did you notice how I was concentrating my heat on the bottom plate?
I did.
Inevitably, that heat's going to rise and capture that and get it melting first. So I automatically know I'm going to start my puddle on the bottom plate, and then by the time it gets melted, the top's already melted, and I can dab it in there.
And I'd have tried to start my weld in the V.
Huh?
I would have tried to start my weld in the V, in the junction there.
Oh, right in the middle? Yeah. Okay, 2 more tacks, and then we can start welding, and I'll show you a couple different ways of doing it. All right. The process that I'm going to use is I'm going to heat, I'm going to add, watch the outside profile, I'm going to back off and let it start solidifying, I'm going to move forward and I start the process over by heating, adding filler until the profile is what I want it, and then I back off, and then I go forward.
Back off on your amperage
Yes.
with the pedal.
Yeah,
Okay.
not dark, you don't want to go stop, right?
Right.
So this is what it looks like.
Okay, so you're pulsing it with the pedal.
Yes, right now with the pedal.
Okay. Very nice.
So I wasn't hot enough yet there, right?
That's nice.
So that's one way of doing it.
Okay.
I could see that I was not hot enough on the bottom plate there yet. So another way of
And
doing
I can
it.
see that in general terms, I'm trying to move too fast.
Yes, slow down. So Jesse James, I worked with him for a week, and if nothing else, he taught me that most people would be pretty good if they just slow down a little bit, right? And that's the only thing great I got out of him.
I watched him work the crowd at Daytona at Bike Week one year.
Yeah.
He was spectacular.
Was he?
You'd have thought everybody that walked up was a VIP. I was totally amazed.
Wow, that's cool.
Yeah.
That's cool. All right, now this one, I'm not going to fluctuate my amperage at all. I'm just going to pick an amperage that has the top and the bottom melting as I want it, and then I'm gonna start feeding and going and dabbing, okay?
Okay, and you're gonna continue to bring the torch forward. You're not gonna be backing up with the
Not
torch.
with this one, no.
Okay, okay.
Not unless the metal wants me to. Like if I'm not real consistent and I didn't get the weld behind it really good enough, I can back
You'll
up.
back up and heat it.
Okay. My instinct wants to pull. Really hard to do this without my foot wanting to pull. It's getting hot toward the end, so I'm having to back off on my heat a little bit.
Here's one of my questions that I have every time I start welding coupons, and that is, it seems like I have better welds when the material's cold than I do after the material's gotten warm or hot.
Yeah,
Is
when you're
there
welding on
anything
the
to that, or
same
is that
thing.
my imagination?
No, it's true. So it just accumulates heat over time. You can see the heat dispersion. See how it started here narrow, then it's getting really wide as the plate's heating up. So I had to back off on my heat because it was getting too hot and I was starting to get some undercut there.
Okay.
So
That's nice.
it's not as bad when you're doing thicker stuff over a longer area.
You know, and on a job site, is this the kind of welds you're looking for?
That's the kind of welds I wouldn't fire myself for.
Okay.
It's not perfect, but I've never claimed to be a perfect welder.
I think it's, yeah, but I'm here for Michael Brandt's take on things. That's what I'm after, is real life welding.
Another way of doing this, and I think I'm going to step up to a larger TIG welder for this.
Can you do the outro?
Oh. Okay, I had a lot of fun with you, Mike. You're going to put you in the seat next, but our audience has to leave now, so say goodbye.
Enjoyed it. Thank you.